We are looking at a continuation of what we did in our previous class, of which I explained the different methods that can be applied when treating differentiation. Remember, I told you calculus is broken down into two parts. We have the differential and we have the integral part of calculus. Now, we have looked at chain rule last week. Now, let's browse through product rule, quotient rule, implicit differentiation, which is one particular aspect of differentiation that is always exempted from the textbook. And then finally, differentials of trig. This trig here stands for trigonometry, of which I'm going to throw or shed more light when we get there. Now, looking at product rule, I did explain in our last class that this word product stands for what? Multiplication. Now, when do you know how to apply or when to apply your product rule? Your product rule can be applied when you look at two terms multiplying each other. Take, for example, you have a question of this format. Let's say y equals x squared plus 3 multiplied by 5x squared plus 6. Ideally, if we are to differentiate this, we will what? Open up the brackets by using the first terms to multiply what? The first and the second term of the second bracket. You understand? And after expansion, we arrive at a common ground. Now, this is what I mean. Let's go. X squared times 5x squared will give us what? 5x to the power of what? 4. Plus x squared times 6 will give us what? 6x squared. Plus 3 times 5x squared will give us what? 15x squared. Plus 3 times 6 will give us what? 18. The next thing is to what? Gather our like terms. Now, what do we have here? Y would now be equals to 5x to the power of 4. Plus, since you have an x squared and you have an x squared, you can add them together, right? Now, let's look at the coefficient. What's the coefficient here? 6. What do you have here? 15. 6 plus 15 will give us what? 21. Then you're going to pick one of these two. So we'll add what? X squared. Plus, what's the final one here? 18. Now, if we had to get the differential of this, y automatically becomes what? dy upon what? dx equals to. Now, you remember the general principle, which I call the second or the shortcut principle, right? What's the power here? 4. 4 times 5 will give us what? 20. What do we have here? X. Then we remove 1 from the power. What is 4 minus 1? 3. Plus, we go to the next term. What's the power here? 2. 2 times 21 will give us what? 42. Then what do you have here again? X. If you remove 1 from 2, what remains? 1. Do we need to write it? No. Plus, this is a constant. Whenever you differentiate a constant, what did you get? 0. So place an arrow and turn this to what? 0. So my final answer for dy over dx becomes what? 20x raised to power 3 plus 42x. Or you can go further as a scholar to factorize. What is common between 20 and 42? X is common. Something else is also common. 2 is also common. So we can bring 2x out, right? So this becomes 2x open bracket. If 2 divides 20, what do we get? 10. If x divides x cubed, what do we get? X squared. Plus, if 2 divides 42, what do we get? 21. If x divides x, what do we get? 1. So you can leave your answer like this. Now, ideally, don't use this format, because there are situations where things might become complex. Let's take, for example, you're having a question of this format. Let's say, let me use this. Y equals to 5x squared plus 6 raised to the power of 4 times x squared to the power of 3. What will you do? You see, it becomes what? Complicated. So I advise students to always apply a general principle for product rule. And what is that principle? It is quite very clear. It is a formula applied whenever you're dealing with product rule. Now, the formula states, first, that if y is equals to uv, in between uv you have a product. True or false? Now, these are my two terms multiplying each other. So what comes to my mind? Which method do I apply? I apply my product rule. My y becomes what? dy over dx equals to. You see this u, write it again. Then the next term is what? V, differentiate it, so we call it dv. Remember that product usually go with addition. And division goes with what? Subtraction. So put your addition since you have a product. Now, the same way you did this first term, do it again for the second term. So what am I going to write first? V. Then if I'm writing V, what am I going to differentiate? U. So what does it become? Du. This formula is used when solving what? Questions that falls under what? Product rule. Now let's take this question and see if we're going to get this answer applying product rule. Are we ready? Now what did the question say initially? Y equals to what? X squared plus 3 on one hand, 5x squared plus 6 on another hand. Now these are the two things multiplying each other. So I can comfortably say this is my U, and I can comfortably say this is my what? V. Now applying this formula, this y becomes what? Dy over dx equals to, what comes first? Is it not U? And what is my U? X squared plus 3 times dv. You already know how to differentiate. If you differentiate 6, what do you get? 0. If you differentiate 5x squared, apply what we did previously. 2 times 5 gives us what? 10. 10 what? X. 2 minus 1 is you know 1. So what is the answer here? 10x. The next thing is to apply my sign plus. Now let's do it the reverse. What comes next? V. And what's my V? 5x squared plus what? 6 times, what am I going to differentiate this time around? U. If I differentiate 3, what do I get? 0. Because 3 becomes a what? A constant. Now, if you differentiate x squared, it's clear. Do you know there is a 1 which stands as the coefficient of x? But normally we don't put it, right? So 2 times 1 will give us what? 2. After 2, what do you have? X. If I take away 1 from 2, it becomes 1, right? So leave it like this. Now let's get our final answer. Dy over dx is equals to 10x x squared. True or false? 10x x squared. 10 times 1 gives us what? 10. X times x squared gives us what? X cubed, right? Okay, we are making progress. Plus 10 times 3 gives us what? 30. 30 what? X. Plus 2 times 5 gives us what? 10. X squared times x gives us what? X cubed. Plus 6 times 2 gives us what? 12. 12 what? X. Next we can what? Gather what? Like terms. 10x cubed plus 10x cubed is what? 20x cubed. Plus 30x plus 12x becomes what? 42x. Compare these two. Is it not the same thing? So which one do you think appropriately should fit for questions like this? Product rule. You can write.